This is Ray's Magnetic Torque Generator 2. I'll briefly go over my setup. I have a disc, and when I turn the disc, it turns a small generator, and it's hooked up to LEDs. And there's 9 in each one. I have 5, so 45 LEDs set up. My focus is having over unity events. And I'm going to go through some of the principles of this device here. And if you saw number 1, you saw that I was working with, I think it was 1 LED, trying to get it lit. So I've advanced a little bit. So anyhow, I'm going to come into the gate. This is called the gate right in here. This is called the input. And for an over unity event, I want the input much, much less than the output. So if I get more output than input, then that's case for over unity event. So I'm coming up here. Let's use my finger. Coming up to the gate. That's the balance point right about there. So that has a self-acting system to it. It grabs it, pulls it through, and throws it through. So I don't have to have any additional force to make it go through the gate. So we'll come up to the gate. You can see that there's very, very little force to bring it into the gate, and then as it fires, your output is definitely more than the input. Okay, this is my drawing diagram, and just briefly, you can use just about any type of setup. We'll go through a couple of those later, hopefully have time. So this is based on a magnetic torquing effect that I've come across. Okay, and that's what throws it through the gate. I'll illustrate the torquing. I have a magnet on a swivel. So here's my, I call this my magnetic converter, kind of a torque converter. So anyhow, you can see that there's a torque here as we go through the gate. So what it's doing is my magnet always wants to face the post. So it swivels so it can always face the post. So that's just standard magnetics there. But if we come through we can see it kind of come around. But if you go straight through, then you have more of a torquing effect. So this is very unique also. We're going to hold this in place, my north facing the north. This is also north. And we'll see what happens. Before it was swiveling, but now the torquing is under control. And you see it going through the gate there. Okay, so now it has a forward force to it, and we'll go through that also, explaining that. It flips, and that's due to the magnetic forces there. And I wanted to go over this part here. The torquing converter, I call this my magnetic converter because it has a torquing effect. But what it does, it brings this torquing effect into a smooth and a one-way magnetic flow. That's what that's doing there. Instead of torquing, if it was loose, we have it now under control, and that's what your torquing converter does. It brings it through. Okay? Also, I'm using a principle called the 90-degree magnetics. And if you can see this here, the forces or the fields from this torquing converter assembly is perpendicular, and this is, I guess, a plane. There's really two things going on here. These are kind of a balancing magnets, and they have a plane this way, but your main magnet has a horizontal plane. So I got to clarify that. And then your activator, I call this an activator magnet, and it has a plane this way. Anyhow, it's 90 degrees, and that's where that phenomena comes through and into play. When you have that setup, it'll take it by itself and pull it through. That's an over unit event by my calculations. Okay. The other thing that's very necessary is to have a distance here that I call it a second story, and I will illustrate that. If I have a magnet here, and see the best way to do this. So right now you can see it's pointing to the south side. But if I go down a little ways, it'll turn over. Yep, it's too close to that magnet. Get over here. Okay. Here's my south side. Not very strong. But if you're coming into something, this will probably show a little bit better. Let's say I'm coming into a magnetic field. This is a north face right here. And let's say I'm coming into a magnetic field here. And it's pushing away. This is a north face also. So it's pushing away. But if I go down, this is called first story, but if I go down to a second story level, it actually pulls through. So your first story has a pushing effect, and your second story magnetics has a pulling effect. I have that over here. You can see that on your first story, the fields are where they push away, but on the second story, they were actually pulling in because it reverses itself. So that's one thing I think people have missed also when they're doing their work for over unit events. You really, where I found it, you need to have that second story to work. If I push that down now, we're going to be into the first story magnetics. See that? The fields are pushing away, but in the second story level, they're reaching out and grabbing and pulling forward. Get that down a little bit more. Coming through. Get down so it fires the LEDs. There we go. So that's a good illustration of first and second story magnetics. So the torque converter or torque generator, the whole system is the generator, but it's broken up into your converter. I call this my magnetic converter because it switches the fields back and forth when you go over it. And your activator is the one that smooths out and brings it into a directional flow, so then you have a smooth firing that goes through. So it's important to understand that the magnets themselves do not possess any moving fields or currents. Only when the movement and the magnetic fields in the proper configuration, then this resultant causes the system to go from a passive, which is over here, this is just passive, up to here, and it goes from the passive, and as the motion gets closer to the gate, then the self-acting system takes place and pulls it through. It takes over. So it goes from being passive to an active, or from a non-reactive to reactive. This interaction of magnetic fields plus the movement causes this self-action to take place. It's actually self-contained, self-acting event. You do not need any further force from the outside once it takes over. This is just, I'm working on an over unity event, that's all. I'm not trying to make a machine that's going to run itself or anything at the moment. This is what this is. So this is my system right now. If you go back to see generator number 1 and compare it to generator number 2, you'll see that this is advanced quite a bit. Also, when you're working with this, I don't really mind having a little bit of pushback. This is just so floating when there's no resistance. This generator and wheel and all the friction causes enough that you don't get these spurious motions, and it starts flying all over the place just by breathing on it. So I don't mind a little bit, because we're going from input to output, that ratio. So your input to your output. So thank you very much. I appreciate that. You can video this and take pictures of it. And I think you'll have a lot of fun. I'll go ahead and put another set of magnets on it, in case you don't have those kind. And what I do, this is aluminum here, so I take a small magnet and put under it to hold it in place. So this is I think that's a 2-inch there, and you can actually go further, closer, to get a better reaction. So just to show you that this is really, if you don't have the right magnets, I don't think there are just right magnets. But I was a blacksmith, and so that's why I started working with the iron, and the iron helps focus things. That's why a lot of my experiments have iron in them. So there you go there, and I'll finish off with a big one. I tried this once and it about tore everything apart, so I thought, well, maybe for the grand finale, I'll go ahead and do this big one. This is a inch by inch by inch. That's a Neo, and I have a big post there. Let's see which way I want to go here. Wasn't too bad. A little closer. So you can kind of see it is scalable, and if you work with it and have patience, you could get some serious voltage out of that. An LED, they fire around 2 volts, so we're at least generating 2 volts for really practically nothing, because the action takes over after you bring it up to the gate. And a lot of systems, they show you after it's into the gate and it takes off, but it doesn't show you really coming into the gate and how much resistance it has. So thank you very much. Appreciate it. Visit my Buy Me a Coffee, and have a good day in Benny.